continue our lesson with logarithms. It's helpful to know what the logarithmic form is. And these examples that I'm working out are on a worksheet. So if you have access to a printer, you can print them off. If you don't, no big deal, because there's not a lot to copy. You just got to kind of write the problems down. So this is the basic idea of what we're working with today. The logarithmic form is being able to convert between an exponential form, something raised to a power equals a number, into a log form, which will be, it'll have log at the beginning. There'll be a number down in the little subscript, that's the base. And there'll be a number in the log or in the parentheses. Usually there's parentheses written, sometimes there's not, but it's understood that if there's no parentheses, then if there's a base there, that's log in the parentheses. We set it equal to y. I want you to notice some patterns, some similarities. The exponent in the exponential form is what it is isolated in the log form. So it's going to be equal to that number. The number in the log is what was isolated in exponential form. So they basically switch places. This little number down here in the subscript in the log is the base of the exponent. So those are the same numbers. So I use like an outback model. I'll take the base of the log and I raise it to that power. So it's like b, and I go out to the other side of the equal sign. I raise it to that power. And then I set it equal to, then I go back into the other side of the equation, and whatever's inside the parentheses is what it's equal to. And that's the same thing. So I go out and I go back. So we want to convert from an exponential to a log. We first want to identify, so 100 equals 10 squared. We know 100 is equal to 10 squared. We want to identify the base of the exponent. And sometimes the base is, it's whatever has an exponent with it. So this 10 there, that's your little b. So to write it in log form, we always start with log. And that number that's being raised to a power, isolate that. That's going to be the number down there in the subscript. The number in the parentheses is going to go from the number on the opposite side. So we go out, and that would be, in this case, the x value, because that's what it's equal to. So it would be log base 10 of 100. Then we come back, and we set it equal to the exponent. And that's writing it in logarithmic form. And remember, the point of these logs is to help solve for exponents. So we want to get comfortable writing it in this form so that we can solve these a little bit easier. Okay, let's do this one here. So identify the base, 81 equals 3 to the 4th power. And the base is going to be 3. So it's going to be log base 3. In the parentheses, we go to the opposite side of the equation. So it's going to be 81. And we set it equal to the exponent. Log base 3 of 81 equals 4. Letter C. The base is going to be 1/2. So we go up to 1/8. So it's going to be log base 1/2 parentheses 1/8 equals 3. Now I want to prove to you this works real quick. So if I look at, again, I want to show you how to use a calculator to type in logs. So if you look at log base 10 of 100 or log base 3 of 81, we can actually, since these are all numbers and not variables, we can check these. Later on, you'll get into variables, so it'll be a little bit harder. But what you can do is you can go into, I'm going to functions in Desmos. Again, you can access that by clicking the keypad, going to functions, and going to miscellaneous. And you're going to do log with a little a subscript. You can also get that by typing in log. To get the subscript, we do underscore. That's a shift and the minus sign. So next to the 0, if you press shift, hold down shift and press minus, see how it puts that underscore there. So that's another way to do it as well. So if I want to do log base 10 of 100, that's going to give me equal to 2. See that? If I want to do log base 3 of 81, log shift minus right arrow, that's going to give me 4. If I want to do log base 1/2, oops, that was a little trickier. Shift, maybe use parentheses. Well, let's use 0.5. And in the parentheses, I would do 1/8. I guess there are some limits to how you can type that in there, but 1/2 is the same as 0.5, so no big deal. So log base 1/2 or 1/8 is equal to 3. So you can get it in this manner too, or you can check it. It's not going to tell you what the answer is. So going back to the problems here, we want to also be able to go the other way. So I want to convert between exponential and logarithm and get it into an exponential form. So in this case, we're going to start with the base again. So identifying the base in the exponential form is just circling the number that has an exponent. Identifying the base in the log is circling that little subscript. So we start with this, we say 2. We go out to the other side of the equation. Raise it to that power, 2 to the 7th. And we come back, and we set it equal to 128. The second one, we identify the base. So it's going to be, in this case, the 5. That's your little base. So we start with 5. We go out to the other side. So in this case, we got to go to the left side. We're going to raise to the 3rd power. And we're going to set it equal to 125. So what happens if there's not a base group? Well, there's something called a common log. And a common log has base 10. Base 10 is kind of the default base. Any calculator that doesn't have the fancy options of putting in a base is going to use a common log, and it's going to be a base of 10. So if it is not written there, we're going to put a 10 there. And that's going to be your default base when not written. It's not 1 or 0, but it's 10. That's important. So in this case, the base is going to be 10. We say 10 to the 3rd power. We set that equal to the number equals 1,000. And so, by the way, on your graphing calculator or Desmos, whatever you're using, if you don't put a base in there, you just type in log and you put in 10,000, it's going to assume it's the common log and evaluate that as if that were a base of 10. And that's the same as doing log. I do shift minus 10 in there. Same thing. So log of 1,000 in any typical calculator is 3. Log base 10 of 1,000 is 3. Okay, to wrap up this video, you're going to want to try these on your own. So I have a few problems here that I'm going to leave up here. I want you to pause the video, and we're just rewriting it in log form or exponential form. So we have leave that up there for a minute. Click pause if you need extra time.
Okay, I'm about to reveal the answers, so if you haven't finished them yet, make sure you click the pause button until you've done it, and you can check them after you've tried. All right, here is number 1. 32 equals 2 to the 5th power is rewritten as log base 2 of 32 equals 5. Base is 2. Go to the other side and then come back. 1/2 to the negative 2 equals 4. That's going to be log base 1/2 of 4 equals negative 2. Rewriting an exponential form, log of 100, that's a base 10. That's your default base, common log. 10 squared equals 100. And the last one, log of base 3 of 1/9 equals -2. 3 to the -2 equals 1/9. All right, I'm going to stop this video, and that's going to conclude that type of example. Next, we'll get into evaluating logarithms. Thanks for watching.